Welcome back. We've gone through a lot of the basics of decision tree. The best way to learn is to apply to a real world problem. So that's what we're going to do here. And the project that we're going to work on is called the IBM HR Analytics, Employee Attrition as well as Performance. We're going to predict the attrition of the available employees. I've provided the link here. And this is the link to the Kaggle datasets. You can download it by clicking on this. It provides the data in terms of the content. What you have is the age, the staff, attrition. Attrition here really means they have left. You have the business travel. Are they a frequent traveler? The daily rate here is not very clear. So let's look at the metadata. No description provided. Oh, that's useful. None of these have description. All right, that's really wonderful. Well, that's not going to make it easy. You have the department, distance from home, education. Let's blow that up. Education, the education field, the employee count, employee number, satisfaction in terms of the environment, the agenda, hourly rate, the job involvement, job level. So you can see that there's actually a lot of data here. Not really, goodness gracious me. This we have 100 rows of data, and in terms of the metadata, there seems to be substantial amount. There's 35 columns of data with this as well. Okay, so let's pull the column matrix up. Let's see what else we can see here. The median age is 36. You have 14% attrition. You have three types of or three categorical. Daily rate doesn't seem to be very informative here. You have three different departments, and the distance from home range from 1 to 26.2. This is really part of the exercise that you have to do, is to understand your data. So you download them individually, one by one. Remember, this is IBM, so obviously they're going to have a lot of contents here. The only key problem that we have right now is that with so many columns, we don't know what is important and what is not. Okay, so that's the first thing that should pop up in your mind. Okay, what else? There are some kernels here. Whereby other people has uploaded. You can actually look at them just to actually get yourself going quickly. What other discussions are there? Typically, when people don't know what they are, they'll probably such as this one, doubts with the meaning of some fields. Yeah, it doesn't say. Right, so let's just close that off. Nobody has answered her question at all. Right, you have some description here. Uncover the factors that lead to employee attrition and explore important questions about show me a breakdown of distance from home by job role attrition, or compare average monthly income. Yeah, it's a fictitious data sets created by IBM data scientists. Yeah, there isn't much to go on. Anyway, so that's really the first step, is to actually get a exploration of the data. I've already imported, I should say import pandas as PD right now. I don't know what I need, so I'm just going to import the usual as NumPy, and also import matplotlib.pyplot as plt, and we just need the chart to be inline so that we can see it within, or have it embedded within the actual notebook itself. So the first one that we want to do is import the data, read CSV. I already downloaded this data, and I had it stored within my data folder, which I will provide for you. And I believe this is a CSV data. No, this is not CSV data. This is Excel data. Oh yes, it is CSV. So CSV. Okay, so after we have import, let's have a look at the data. All right, so that's really what we have. It looks exactly the same as before. Good, today download has come through really well. So let's look at the shape. We have 35 features and 1,470 so-called samples. I think a couple of things is that, as is with most data scientists, you need to actually munch your data a little bit, beat it into shape so that you can actually get some useful information out of it. Couple of things that's probably irrelevant or fairly useless. I think I covered this when we looked at it earlier. Let me see if I can view this well. I think such as employee count. Notice that it's all 1. That's useless. Employee number is also useless. It's just a generic number. It has no meaning whatsoever. What else can we take out? So let's just employee count. We bring that over here. That's one that we want to remove. Employee number is also the other one that we want to take out. What else? Let's just see. Have a look through the data. This is how it's not very exciting, but it's necessary for us to actually make sure that we're not gonna get data that is that will mess up our analysis. So over 18, again, that's fairly irrelevant. Most of the staff will be over 18 anyway. Let's see, what else do we have here? Standard hours. This is all 80. Yep, they are all 80. Okay, so that we will take out as well. Right. Okay, that looks like all the data that we have that we can make use of. So df pop. That's how you remove a column. Okay, so let's just run that. Yep, that's gone. All right, so when you look at df columns, it should not have employee count. Yep, that's not there anymore. So we just repeat that for all of these. We're likely to get an error because we've already done the employee count. So never mind. I'll just put that to the end. Yep. Okay, so just restart and rerun this and let it run through the whole thing. Okay, so now the over 18 shouldn't be there no more. Yep. Okay, so let's look at our df shape. It's now 31. So all these 4 columns have now been removed. Right, having done all that, the next thing that we need to do now is to actually shape the data. Okay, having run all that, we now need to actually pick the target variable. In this case, we are trying to train the so-called attrition as our target variable. So let's look at that. Let's pull that up. We want to actually store our data. So with our y, it's going to be the attrition. Okay, with our x, it's going to be the whole thing, the whole data frame. However, we do want to remove attrition. Okay, all right, that went okay. So the next thing now is just to have a look at our y unique. Okay, so is that the yes or no? Okay, so with that, we need to actually make use of the scikit-learn pre-processing from scikit-learn. Okay, import pre-processing, because we do want to actually convert the label from yes no, because we're going to have an error otherwise when we actually try to fit our model. Binarizer. Okay, right, so and we're going to fit transform the whole y and store back into y. Alright, label binarizer has no attribute fit transform. Okay, so I think we need to run this first. Okay, having done that. Okay, so now fit transform y. Yep, that's fine. So let's just store that in y. Okay, so that's fine. So okay, so basically we have now tidied up our Y shape. And the next thing now is to move on to tidying the X data. Notice that there are a lot of categorical data here, so we need to tidy those, otherwise again we're going to get an error. Okay, so having done that, now the question now is how do we actually find all the categorical columns? Data frame has this neat feature whereby first of all you can actually look up the actual data frame itself, and you'll notice that there's the object, there's the object, there's an object. And the integer 64 naturally means they are all continuous variables. The object here, so let's just look at the first one, business travel, and let's come up here, business travel. Yep, that's an object. Department, also an object. Okay, then that's fine. So next thing we need to do is select those. You can select D types. This is the inbuilt function, and just type object or BJECT, and here you go. And what you have now is that you've selected these columns, which are all objects, right? Now, having done that, the next thing that we want to do is actually convert all of these to continuous variable, or convert it to a number to actually allow the scikit-learn to be able to process this and to fit the data. Now, there's two ways to do this. I already taught you the pre-processing method by using one-hot encoding. I'm going to take a shortcut and use a different method that's provided by pandas. So how do we do this? Basically, you use pandas and you get dummies, okay, and you enter the actual column itself. What we have here is business travel, and we have to specify a name for this, prefix this, and I think I'll just keep it to that rather than making too many modifications. And we just use an indicator and calling it business travel. Okay, and we just have to repeat this few times. All right, so okay, so let me just do this. 2, 3, 4, 5, 6, 7. Okay, so department, we just change it to department, but with an indicator, and we call this department and department. Yeah, this seems to be a bit boring, but trust me, this is actually much faster than using the one-hot encoding. Which is actually a two-step process where you have to first convert your values into integer first before it actually separate them into the final outcome, which is the one-hot encoding. Okay, so having done that, and last one now. I'm sure there's an easier way to do this, which is using a for loop. But for now, I want this to be nice and clear. All right, we're finished running it. So let me show you what it looks like. Just show you the head part, the first few value. We have an extra close column here. All right, so you're looking at this. What you've done is really just, there are three types of unique variables, unique data, so unique. Okay, unique. And that's travel rarely, travel frequently, and non-travel. You have the business travel, you have a non-travel, you have travel frequently, and finally travel rarely. And basically these are all indicator. These are basically one-hot encoding. If it's rarely, it's 1. If it's frequently, it's 1. So the reason we do this rather than 1, 2, 3 is because when you apply 1, 2, 3, the machine learning algorithm, it thinks that 2 is more important than 1, 5 is more important than 2, on and go. So that's why we use this kind of indicator variable, which allow us to quickly get up to speed to actually allow them not to actually have any issue at all. Okay, the next thing that we want to do is combine all of these into one data frame, a new data frame. Okay, so having done all of that, there are no shortcut to do this, so I'm just going to have to copy all of these by concatenating them. But I need to actually put providing a list That's column there. Okay, followed by the department, followed by the education field, and followed by the gender, and followed by the job role, and marital status, and finally overtime. Okay, so now that we've done that, now recall that earlier when we're selecting the objects, right, we basically look for the categorical. We can actually do one more thing just to take a step further. Integer 64, we can select all of the types, data types as int 64, right? Okay, so what can we do now? So we want to actually basically create a brand new combining the continuous data as well as the transform data. So instead of going this one extra step, what we can do is actually just select our include at the end our data frame, which select these. Okay, and one other thing is that we do want to specify the axis is equal to 1. What that does is that it will force it to actually combine, zip them up row-wise. Basically, we'll retain rather than having stack, they will actually row-wise. I need to remove this. Okay. All right, that's done. So let's look at the shape. What we have is the same number of rows of data, except now that the columns has increased substantially, the reason being of the indicator variable that we actually prepped before. Right, so this is really the preparation video. Now that we have done the preparation, the next video we're going to go into the train split and also training our fitting our classification tree to the data itself. So this is called loading and pre-processing. Alright, having done all that, I hope you actually typed and follow along. If not, I so strongly suggest you to pause the video and just try to see if you can do a couple of things here. One is download the data directly from Kaggle and then import it into the Jupyter Notebook. Then the next thing is to actually tidy your data so that it's binarized, especially those which are categorical, and combining your categorized data which has been transformed with your continuous data. So those are the few steps that we've done, and when we come back we're going to start going into the fitting of our data. Thanks for watching.